Hey there, guys. I hope everything's going well for you today. Today is going to be the logarithmic side of these equations that we are trying to solve. Now, I think that just from those last examples that we just did yesterday, I think that we can kind of get our hands on what's going to be going on with these. Yesterday, we tried to get whatever was being raised to a power by itself. Well, today, we're just going to do the opposite of that. Whatever we're taking log of, or in this case, natural log of, I want to get it by itself. So everything else that's going on around it, I want to add or subtract or multiply or divide or whatever's going on with it, all the way down into where I can just get that natural log of x by itself. Okay. Now remember, this natural log of x is actually log base e. And so to rewrite it as an exponential, the e goes over and bumps up this 5/4 to the exponent. And that is my exact answer. And just like yesterday, I want an exact answer, and then I want a 3 decimal approximation. So I'm going to find that e button on my calculator. E raised to the 5/4. So we'll do 3.490. Pretty basic. Try part B on your own, and let's see. Got a few more steps at the end of that, but I think you can figure it out. So then pause the video and give it a shot. 2.216 is what I got on that. Be careful. I went ahead and sent this e over. The only thing I had right here was the natural log of something. So I'm ready to send the e over and bump up to 1/2. And then notice I didn't put anything in my calculator until I get all the way down here to the end. So I have my exact answer, and I have my 3 decimal approximation. Now, just like yesterday, we had some easy problems. Today, hopefully, we're going to try to, if we're not given an easy problem, we're going to try to make it so it's an easy problem. Because my goal is to make it so that whatever I have log base of on one side, I get that same log base on the other. And whenever that happens, these log bases will just cancel, and I just get s equals t. You're going to hear me refer to that as the one-to-one property of logarithms. Okay. Now, you want to make sure you're checking your solution like it says there. We do get the opportunity to have extraneous solutions, solutions that must be rejected because they do not satisfy the original equation. So make sure we're checking our answers to see if that makes sense. Okay. So I'll talk about that as we go through. So looking at this one, man, they are so nice to me right here. They just gave me natural log of something and natural log of something. In order for these two things to be equal, whatever I'm taking the natural log of has to be equal. Great. The reason behind that is because I'm actually exponentiating both sides. So for this one-to-one property, this is all I really need to know. So the only way I saw something that looked like this earlier this year is where everything was on one side and it was set equal to 0. Yes, factoring. Factoring is back. So I get x minus 3 equals 0, x plus 1 equals 0. So I get x equals 3, x equals negative 1. What I want to do is I want to plug this back in to make sure that these fit inside the domain of my logarithms. If I plug a 3 back in, then yeah, I'm good. Right? It would give me a 9 on the right side. If I plug a 3 in on the left side, and I plug a 3 in on the right side, it gives me a 9 as well. I'm just checking the arguments on it. If I plug a negative 1 in on the left side, it gives me a 1. If I plug a 1 in on the right side, it also gives me 1. So I feel very confident in both of these answers, especially if you're going back and checking them. Now this one gets missed a lot. What a lot of people say is, okay, well yeah, I just have log on both sides. Do they try to subtract off the log? That last problem was easy because I just had a single logarithm on one side. And that's what I want to get to here. Let's see if I try to subtract off this log base 2 from both sides, this 3 right here gets in the way. So that's a no-go. Can't do that. Instead, what I'm going to do is I'm going to think back all the way to my log properties. I had a log property that allowed me to take two logs that have the same bases, and I use the word condense down to a single logarithm. That's going to help me out tremendously on this problem if I can remember that property. Well, it said it was my product property, and it said that if I have log base 2 of two things being multiplied together, I could split apart these two products as long as I put a plus sign in between. Well, that's exactly what I did here. I just worked it in reverse. So I'm wanting a problem that looks like this. Now from here, I'm going to use my definition of logarithm where the 2 comes over and bumps up this 3. And I'm pretty sure I'm going to need to FOIL or distribute twice on all of this stuff. I got some cleaning up to do. I got minus 4x there plus 3. And I'm just hoping this one factors at this point. I get x squared minus 4x. Let's see, if I subtract 8 off both sides, that gives me a negative 5. Ooh, I lucked out, it factored. So x minus 5, x plus 1. So I get x equals 5 and x equals negative 1. Shadow got the win on that. And then what most people do is they go on to the next problem. Well, that's where Mr. Lovelady's going to pull out his red pen and he's going to put a little minus 1. Why? Because I did not check my answer. Okay. This time it's going to matter. And I'm going to tell you when you need to check your answer is I'm going to take this 5 and I'm going to plug it back into the original. That doesn't give me any problems with this argument. It gives me 4. And with this argument, when I plug in 5, it gives me 2. Those are two nice, healthy whole numbers. The problem's going to run into whenever I try to plug in this negative 1. Let me use black on it. When I try to plug in that negative 1, I get negative 1 minus 1. I'm trying to take log of a negative number. Remember, that's a no-go in my calculator. If you don't believe me, use change of base formula to compute that. It's going to give you a domain error on either one of these. So these are a no-go. Let's see. Plugged in negative 1, so negative 1 minus 3. Sorry, that was negative 4 here. So that's a no-go in both instances. You need to let me know that this is not your answer here, and that you only want me to check your x equals 5 as your final answer. That will get rid of that 1 point I have to take off. So be careful on these. Plug them back in. Make sure you're not taking log of a negative argument. So the problem got very easy whenever I was able to condense it down to a single log. So this one's going to be a little bit harder to condense down because I have a log over here and a log over here, and there's this 1 in the way right there. I can't combine these in any way because the 1 doesn't have a log. I guess I could write it with a log, but it'd probably be just as easy to get everything that has a log over here on this left side. So I'm going to take this log base 3 of x plus 2, and I'm going to subtract it off both sides. It gets rid of it over here, and on the right side, I'm just left with a 1. Well, why would I do that? Because I'm also able to condense down logarithms whenever there's a minus sign in between it. Remember what I had to do different? I don't multiply them anymore. It's a minus sign. Quotient rule said if I have log base 3 or log of any base of a quotient, I could split apart this log base 3 to both the top and the bottom and put a minus sign, which is what happened on the step before it. Again, my definition of a logarithm is going to allow me to move this 3 over, and I get 3 to the first power. On the left side, I have 10 minus x over x plus 2. Have a nice linear equation here. Same thing, we don't like fractions, so let's go ahead and multiply both sides by x plus 2. So I get 10 minus x equals 3x plus 6. Oh man, let's live dangerously and bring all the x's to the right side. And subtract 4 from both sides. 6. I subtract 4 from Isn't that going to tell me about that? Let's subtract 6 from both sides. It's working one step ahead right here. All this work, and we get x to be rinky-dink 1 right here. Let me check it, though. I might not have a solution at all. Let me check it. If I plug 1 back in right here, it gives me a 3. That's a nice, healthy, positive argument. That's what I want. I plug in a 1 right here, I get 9. A nice, healthy, positive argument. So I feel good about my answer. X equals 1. Austin Powers came out whenever I was in high school. And after I saw this, I realized I would not be able to handle being a dentist. But it says when he has a cavity filled, the dentist physically administers a local anesthetic. After leaving the doctor's office, Austin's mouth often feels numb for several more hours. If a shot of anesthesia is injected into the bloodstream at the time of procedure, t equals 0, and the amount of anesthesia still in the bloodstream t hours after the initial injection is given by this. See this in the next video, I think. How many hours will only 10% of the original anesthetic still be in the bloodstream? Wow. And how many hours? So we've solved this when we've actually plugged in for t. Now we're trying to find t. So at time equals 0 right here, I have 100%. 1.00. 100% of the anesthesia in Austin's mouth. And then it wants to know when only 10% is going to be left. So how much t do I have to put in there in order to get this down to only 10%? Now, if you're like, why is he using decimals? I actually could just use 100 right here and 10 right here. It's not going to matter because my very first step is going to be, well, dividing by 1. And that's just going to give me 10% no matter what I do. So this goes back to a problem that we had yesterday where we're trying to isolate the exponential, which is what we did, e raised to something, and then now I'm going to send this e over underneath this log. Okay. And so whenever I do that, that gives me log base c. That's just natural log. Natural log happens a lot. Negative 0.05 t. I'm not super interested in. I did it again. Apologize. Here we go. I'm not really interested in an exact answer on this because it's a word problem. An exact answer doesn't make just a whole lot of sense. But let's just round this and say what to round to and how many hours. Let's just do like 1 decimal place on that hour. Well, 10% of the anesthesia is still moving. And so this whole side cancels right here and stuff with t. So I'm wanting to take the natural log of 1/10, and then whatever that gives me, divide it by negative 1/2. 4.6 hours. So even after leaving the doctor's office, 4.6 hours later, he is still going to have some of the effect of that anesthesia. Good luck to all you dentists out there. I do not envy your profession whatsoever. Here's just kind of some general notes and strategies I used in this video to solve for logarithmic equations. And so pause the video, read over these if you want to, but I think a lot of the homework should follow with what I did.